Welcome you all to the week 2 problem solving session of Basic Calculus 1. Myself Guru Bachan from Department of Mathematics, IIT Jodhpur. I am working in the broad area of fractal geometry and dynamical system. This particular problem solving session is devoted to the topics transcendental and trigonometric function, limit of functions, and algebra of limit of functions. So let us start with this trigonometric function. Specifically, if I would say, what is the period of function? So let me define formally what is the period of a function. So a function fx is periodic if there exists a positive number p such that f of x plus p is fx for all x in the domain of f. And the smallest p is known as the period of f. So periodic means when a function starts repeating its values after certain a period, and period is the smallest number after which the function starting repeating itself. For example, so this is the graph of y equal to sin x. So if you will observe here, this is minus pi by 2, this is minus pi, this is minus pi by 2. Oh, sorry, this is a graph of cos x. For sin x we need to draw so this is the graph of sin x. This is 0, this is pi by 2, this is minus pi by 2, minus pi and pi. So if you will observe that, and this value is minus 1 and this value is 1. So if you observe that after this pi by 2, here it's starting from minus 1 and it goes to 0, and after that 0 to 1. But after 1 it's going to again this 0 and this minus 1. So if you will observe that after this pi, this is starting repeating this one. This portion is kind of repetition of this one, and while this portion is repetition of this one. So that means this sin x has certain period and it's a periodic function. So what is the period of sin x? Any guesses? What is the period of sin x?
2 pi.
2 pi. So the smallest number is 2 pi, after which it starts repeating itself. So if you will observe from here, I am just roughly saying, if you start from this 0, it goes to 1, then 0, then -1, then to 0, and after that it will be like this again. So after which is starting repeating itself 2 pi, and you started from 0. So the easiest way to calculate it, the period is 2 pi. So let me give you some problems over it. What is the period of the following functions? The first one is sine 2x. We have drawn the graph of sin x. So in the same way, you may draw the graph of sine 2x, and then you can see the period of this sine 2x. Try this one. Any answer?
Sir, pi.
Why?
Sir, if we draw the graph, then we will get at pi by 4, we will get value 1,
Hmm.
and at pi by 2, we will get 0.
So sine 0 will be 0.
0.
Just what we do, we just draw table for some values. So here is x, and here is sine 2x. For 0 it is 0. For pi by 4 it will be
1,
pi by 2,
0,
then pi,
0.
pi,
Yes, sir, pi will be 0. Next
and
value we will take is 3 pi by 4. After pi by 2, 3 pi by 4,
then
-1, pi, 0.
and if we go for the negative ones, minus pi by 4 it will be minus 1, minus pi by 2 it will be 0, right?
Yes, sir.
So let us draw over it. So this is suppose pi by 4, pi by 2, this is 3 pi by 4, and this is your pi. So it will go like this. So this will be pi by 4, and it will go and again in the same way. So this will be your minus pi by 4 and minus pi by 2. So it start repeating after this one. So this is your pi by 2, this is your 3 pi by 4, and this is pi. So clearly the period is pi. So in the same way, try for cos pi x. What is its period and what is its graph? So if you put values at 0, cos 0 will be 1. At half, here will we not put pi by 2, 3 pi by 2, because here already is pi in the multiply of x. So we will put 1 half, 1 by 4 like that. So cos pi by 2 is 0. Sorry, cos 1 by 2. Here cos, next is 1. Cos pi is minus 1. In the same way, let me go one more value at 3 by 2. 3 pi by 2, it will be again 0.
0.
And for minus half, it will be 0.
0 is, sir.
And for minus 1,
Sir, minus 1. 1.
1 or minus 1.
Minus 1. 1, I mean.
Cos is an even function and odd function. Tell me that.
Even.
Even function or odd function?
Even, sir.
Even. So does it matter? It will be cos pi or cos minus pi.
Oh, no, sir.
Okay, understood?
Okay.
So at 0, it is 1. It will start from here. At half, it will become 0. At 1, it will become minus 1. At 3 by 2, it will become 0. So it will go to here, then here, and after that it will again go like this till which value? 2. In the same way, if you will draw here, so it's just an approximation. So it will be minus half, minus 1 and minus 3 by 2. So from here, what can you say about the period? See, you start from here and after which it start repeating.
So 2,
Here let me write for 2 it will be
1,
1 and for 5 by 2 it will be
0,
0. In the same way for minus 3 by 2 it will be 0.
0.
So here period will be 2. The reason is, if you will observe here, you start from this 0, this position will come again at 2. So that means the period is 2. Now do it for cos x minus pi by 2. What is its period? What is the graph of this cos x minus pi by 2? So how will you draw the graph of this cos x minus pi by 2? What is cos x minus pi by 2?
So we can write it as
Sin
cos
pi
of
by 2.
pi by 2 minus x.
As I said, it's an even function, so we may write it. So it will be
Yes, sir. And now, sir, by computing sin x,
sin x. Good. So this is nothing but the graph of sin x. So what is the graph of sin x? We have drawn here this one. So what is this period? Again 2 pi. Now the last example over this period, sin pi x by 3. If you will observe, there is a pattern in going on in these periods. If you know the period of sin x, then you can directly tell the period of sin 2x. How? Any observation? What is changing? What is the period of sin x?
Divided by 2.
Divide by 2. And here divide by pi.
Y.
But here there is no change in period. Why? Because addition and subtraction is not changing this period. Okay. Only multiplication affect the period. So what I can say, if f has a period, if period of f is suppose some t, then, or you can say it will imply period of f, and I'm talking about any fx, then period of f of ax is t divided by mod a. The reason is we are only talking about positive period. Period is always positive. So what will be the period of this function?
2 pi into 3 by pi.
Into nahi, divide.
Pi by 3 into 3 by pi.
Yes. So what will be the answer?
6.
6. Clear? So this is all about the period of a function. So
Sir,
next,
can I ask one doubt?
sorry,
Sir, why are we finding this period thing?
why are we? Why are we?
Finding the period of a function. Its use.
See, it's a property. You can say, suppose you have to calculate a function value. For example, sine higher value. For example, I wrote 1024 pi, something like that. So what you will do? You will clear out the multiple of 2, because after 2 pi sine is going to repeat itself. Then you will calculate what is the value of that sine x. For example, if I am writing here suppose any cos 1025 pi by suppose any 3. So what you will do, you will divide it and you will see the 2 pi multiple, you will extract the 2 pi multiple, then you will calculate its value. Okay, so next is 1 function. So how many of you know about the 1 function?
Sir, I want to ask a doubt.
Yes, please.
Sir, in the assignment, there is a question sine of 1 upon x, and it is asked about its range and whether it is periodic or not.
Okay, then what's your question?
Sir, that is the question. I want that
Obviously it's
solution,
in
sir.
an assignment, I cannot tell you here because it's for your problem. I can just let you know that sine function, what is the domain of sine function?
Sir, any real number?
To
Sir, domain is any real number.
range is,
To minus 1 to 1.
Negative 1.
Yes, sir, minus 1 to 1.
that's all for the timing. I can let you know its domain is real number and its range is between -1 to 1. Okay, now you have
Sir,
to think about it, how you can combine this sine function sine x with 1 by x. Okay, in the next class only I can discuss, or you can watch the lecture. In that you might get some hint over sine x. There is a example on which sine x has been sine 1 by x has been discussed. Okay, so tell me about 1 function.
Sir, in that one function, every elements in the range have only one pre-image on the domain.
Okay, so if I draw suppose some set, suppose there is any 2 point, there is a function defined from this domain and this is codomain. So with respect to these, is this a 1 function?
No.
No, this is not a 1 function. Reason, we got 2 points who has the same image. So there are two ways to write it. One is f of a is equal to f of b, then if it imply a equal to b, or alternative way is for any a not equal to b, it will imply fa not equal to fb. Is these the two ways? Any of them if follow, then what we say? I hope you know the symbol of meaning of this. Do you know the meaning of this symbol?
Vice versa.
Vice versa. If and only if. If and only if. We can move from any side. Okay. So this definition is clear. If a is not equal to b, then f of a should not be equal to f of b. or the method to prove it, you start with f of a equal to f of b and you prove it a equal to b. So let me give you some example over it. Examine which of the following functions are 1 1. The first one is f is a function from R to R which is defined as fx equal to 3x minus 5, while g is a function from R to R which is defined as x square. Tell me out of these function which is 1 1 and which is not 1 1, and what is the counter example if it is not 1 1, and if it is 1 1 then what is the proof of it. Try. Any answer?
The first one is 1 1, second one is not.
Reason?
The first one, when we substitute f of x1 equal to f of s2, we get 3x1 minus 5 equal to 3x2 minus 5. Cancelling out, we get x1 equal to s2.
Okay.
But in the second one, x1 square equal to s2 square does not imply x1 equal to s2, because it can be negative also.
So to prove anything, what we do, we start with a general statement, that is f of x1 is equal to f of x2. So what it will imply to you, 3x1 minus 5 is equal to 3x2 minus 5, and it will imply x1 equal to x2. Therefore, f is 1 1. While if you try to do it for this second one, that is the function gx1 is equal to gx2, so that means x1 square equal to x2 square. So that means x equal to x2 or x1 equal to minus of x2. We have two possibilities, so it's not general, so we cannot say it is a proof. So we can find out one example in which x1 is not equal to x2, but still their images are equal, and this second one is giving you hint about it. G of 2 is 4, and what is g of minus 2 is, that is also 4. So from these you can conclude that g of 2 is equal to g of minus 2, but 2 is not equal to minus 2. Thus g is not 1 1. I hope it is clear to everybody. So here the domain of f is R to R, domain codomain, or you can say any A to B in general. So it is any A to B, where A and B are subsets of R. So in the same way, if I ask you about onto, what is onto? What is onto functions? So f is defined from A to B. So this is A, which is nothing but the domain of f. This is B, this is codomain of f. So it mapped to some subset of this codomain that is known as range. So range of this f is a subset of codomain of f. So it might be equal or it can be a proper subset. So in those cases, when range of f is equal to the codomain of f, we say our function is onto. So f is onto if and only if range of f is same as codomain of f. Clear? So tell me, check which of the given functions are onto. The first one is r to r as f of x is equal to x square. B, g r to r as g of x is equal to e to the power x. Tell me which of the function is onto. What is the range of?
Sir, no,
Yes, please.
no one, sir. Sir,
No?
no function is onto.
Okay. So how, why the first one?
Sir, range of first function is 0 to infinite, 0 closed.
Okay. And
So it is not equal to codomain.
codomain of f is
R.
R. So range of f is not equal to codomain of f. Therefore, f is not onto. Now tell me about what is range of G.
Sir, it is also 0 to infinite, but open bracket.
If I would put plus it here, then
Sir, then it would be onto function.
so I hope it is clear. R, what is the meaning of this R plus? In classes, in the lectures, R plus is denoting with subscript. So R plus means the collect all positive real numbers. So here range of G is 0 to infinity and 0 is open. What is the codomain?
0 to infinity.
So this is nothing but R positive and this is also R positive. So therefore G is
Odd.
onto function. Is it clear?
Yes, sir.
So now tell me, we know about 1 1, we know about onto. Can we talk about the inverse of a function? Suppose you have a function f a to b. When its inverse exists,
When it is both 1 1 and 1 2.
why?
Otherwise, it will have more than one inverse value in the domain function if you find the inverse.
So it means f inverse exists if and only if f is 1 1 and onto. What is the reason? So f inverse meaning what? So f inverse of any y is nothing but x. For fx equal to y, if we write, so that means f inverse of y is equal to x. So it will happen only when you can guarantee for any, suppose there are two numbers here who has the same image. Suppose f of 1 is 2, f of minus 1 is also 2. When will you talk about f inverse of 2? Then it will be what? 1 or 2? Oh, sorry, 1 or minus 1? Can you guarantee about it? So we cannot guarantee about it. So what we are saying, if we take our function to be 1 1 on 2, that means only every member map to one member of it. So then we can guarantee about this inverse, existence of this inverse, and also we can tell what is the inverse of it. So the next question is, check the inverse of the function exist or not, and if exist, then find out fr to r f. So tell me, its inverse exists?
No,
No,
sir.
sir,
Why?
because it is not 1 1.
It is not 1 1 as we have seen in earlier. Is it onto?
No, sir.
No, sir.
So F inverse does not exist. But if it, can we make it 1 1 onto? Suppose we define some new g function from this F. What can I do that it will become 1 1 onto? Suppose I am defining from R to R positive. Now is it 1 1 onto?
Sir, if R positive to R positive, then there is chance.
Okay. Why not R to R positive?
Because if in the domain negative number comes, then also the 1 1 function is called.
So in this case, function will be not 1 1, right?
Yes, sir.
And what will be R positive to R? What will be the problem in this?
So not
Given by
onto.
onto.
Not onto. Now suppose some new function we define, some R positive to capital F, R positive to R positive, as f of x is equal to x square. Now it is 1 1 onto.
Yes, sir.
So its inverse will exist. So now it is 1 1 and onto. Therefore f inverse exists. And what will be at f inverse? Under root of x. Why? Let x square equal to y. So it will imply x is equal to only under root y. The reason is we are only taking positive numbers. So that means f inverse of y is under root of y. Is it clear? Okay. So next, let us move to limit of a function. So we start with some example. Now you can say question. Calculate limit extending to 0 fx b limit extending to 1 fx, and the function fx is given as, this is your x, this is your y, it is given as so this is 1, this is 2, this is 1, this is minus 1, and this is minus 1. So we have given this function, we need to calculate the limit of this function at x equal to 0 and at x equal to 1. So what is the limit of a function? How you see it?
Sir, we check first left hand limit, then right hand limit, and if they are
I will go by the class. In the class, I don't think so the left hand limit and right hand limit has yet be taught. So just try to be restrict at what has been taught in the class. Any other answers? See, the limit means the concept of limit comes because um, sometimes we don't know the function is not defined at that point. For example, here function is not defined at 0, or you can say it is defined f0 equal to 1. So in that scenario, there might be a possibility that the limit at that function is different from that value. How? So we talk about if x is near 0, then fx is near which value, that we have to think. So if you think about f x is near 0, near 0 means here it is 0, and near to it means you are taking this much distance. For example, this is some 0 minus delta and 0 plus delta. So where is fx actually? From this side and from this side. This is also near what? Tell me from the diagram.
0.
Negative 0.5.
Near will be 0.
Okay. Yeah.
So that means limit x tending to 0 fx will be 0.
0.
In the same way, if you have to talk about 1, then if x is near 1, then if you see from the left hand side, that is, this is your 1 minus delta and 1 plus delta. From this to this, it is going to where?
Negative 1.
Minus 1.
Negative 1.
But from here, it will go to
0.
0. So from left hand side of x equal to 1, fx is near minus 1, but from right hand side of x equal to 1, fx is near 0. So can it be possible? Tell me. Can there will be two limit for the same point exist? Anyone?
Sir, how the RHS is near 0?
Here function is approaching to which value? Which axis?
0, sir. Okay.
Okay, this is 1
Okay.
at x. Okay,
Okay.
this is not functional value. So can we guarantee this one that I wrote? Limit does not exist. Why? Because
Because function is approaching to values.
no, it is approaching to minus 1, it is approaching to 0. So why is not existing limit? How can you claim that? I'm asking about it.
So because from if we come to that point from right side, the approaching value is different, and
Yes.
from left side it is different.
Yes.
So if it's not same, so we cannot take a unique value.
Exactly. This is the one property of being a limit. So limit x tends to c, fx is unique if it exists. This is a property of limit of a function. So it must be unique. But here it is coming out to be different. That means limit will not exist. Clear? So do the same for the next one. Examine the limit exists or not rather than check. Check this one. In the same way you have to check it. Any answer?
So it will not exist.
Why?
So if we take any positive real number, then we will get x by x. It will be equal to 1. And if we take any negative number, it will be equal to -1. So if we approach from right hand side, we will get the value as 1, and from left hand side -1, so it's not unique.
Good. This time you are precise with the uniqueness one. So the definition of mod x says that it is x if x greater than 0, 0 if x is 0, it will be minus x if x is less than 0. So from here, if you see x by mod x, so this will be x by x if x is greater than 0, and if x is equal to 0, obviously it is not defined, that case is excluded. That is why we are talking about the limit, because there are many functions that are not defined at 0, but their limit exists at 0. So x by minus x. So this will give you 1 minus 1 if x is positive, if x is negative. So this is minus 1, this is 1, this is your graph of this function. So clearly when you take the neighborhood of this 0, so under this will be your image, but under this will be your image. So here it tells you that from the left hand side it is the neighborhood of minus 1, and from the right hand side it is the neighborhood of 1. Thus there is no existence of unique limit. Therefore we can say that limit x tending to 0 x by mod x does not exist. Any doubt? Okay, so now calculate limit x tending to pi cos x divided by 1 minus pi. Next one is limit x tending to 0 1 minus cos x divided by sin x, and the another one is limit x tending to minus 1 x cube minus x square minus 5x minus 3 divided by x plus 1 whole square. Calculate these limits. And you should calculate with the proper limit properties or algebra of limits following those rules. I'll ask at each step which rule you are using. Here is a typo. This is x sine x denominator. So tell me about the first one. What is the limit? So how you are calculating? First of all, there are how many functions? This is 1 minus pi is scalar or function?
Scalar.
Scalar. So you know that limit x tending to c, any scalar times of this fx can be treated as k can come outside, and this will be limit x tends to c fx. So it will be 1 by 1 minus pi limit x tending to pi cos x, right?
Yes, sir.
So what will be limit x tending to pi?
One.
Again the same mistake. Cos pi is 1 or minus 1?
-1.
Minus and source.
So it will be 1 minus 1 by 1 minus pi, or you can say 1 by pi minus 1. Okay. For continuous function, we can directly substitute the limiting value. Now in the second case, limit x tending to 0, 1 minus cos x divided by x sin x. Now check, there are two functions. Now check, denominator is being 0 at any point. When x is near 0, denominator is 0.
Yes, sine 0, 0.
Okay. What about the numerator?
That also 0.
So that means there is a possibility that existence of a limit. If numerator is non-zero and denominator is going to 0, then we can say that our whole limiting value will not, might not exist, or you can say guarantee about that it will not exist. So here there is a possibility. You have to do some manipulation. So what is the identity of this limit? This 1 minus cos x. What is the identity of 1 minus cos x?
2
2
cos
sine square x by 2.
2.
Yes. 2 sine square x by divide by x. Since here it will become x by 2, you have to also break this sin x also, right?
Yes.
So it will be,
2 sin x by 2 cos x by 2.
so from here 2 cancel out, and 1 sin x by 2 is will cancel out. So it will be sin x by 2 divided by x into cos x by 2, or more precisely if I would write, I may write it 10 x by 2 divided by x. Correct?
Yes, sir.
Now check, is it again the 0 by 0 form? Again numerator is 0 and denominator is being,
Yes, sir.
so now what will you do?
X divided by 2 into 2.
Okay, then
Then the identity tan x by 2 by x by 2, 1.
why?
Mm.
You are correct, but there is some reason, no?
Mm. Reason.
So let me do in the way sine x by 2 divide x by 2 into 1 by 2 cos x by 2. Can I write like this?
Yes, sir.
F into g, its limit x tending to c exist when So this exists if both the limit exist. So to exist this whole limit, we must be aware about that both the limit exist. So what about this 1 by 2 cos x by 2? Is it existing? Limit x tending to 0, 1 by 2 cos x by 2. See, I can use the 10x by 2 divided by x by 2 is 1. But I want to let you know how to use the properties. So what is this value? 1 by 2. Any problem?
No, sir.
So in class, you have learned about sandwich theorem. Have you remembered that?
Yeah, if two functions have similar limit, then the third also have the same.
So you know that sine theta lies between minus mod theta plus mod theta, or so from this what you can say, sine x by 2 divided by x by 2 will lie in between minus 1 to 1. Is it correct? Does it work out? Will it work out? Will this expression work out, or we have to think something else?
Sir, can you explain that one more time? How we reach that?
See, I told you that this product limit exists only if separate limit is existing. So first of all, I see this one, this is existing, so it's fine. If this also exists, then we can guarantee about the product limit is also existing. Okay, so I have checked this one. Now what is I need to prove that this limit exists or not? So in class there is an example that include that sine x by x is 1, or you can say x sine x is 1. So how can you claim this one? That sine x by 2 divided by x by 2 is 1. So you need to claim this. So how will you do it?
Sir, should we take the range of sin x,
Okay, then
then make adjustment like sin x by 2 is like between -1 and 1.
okay, then
Then, oh, then let's wait.
so I am telling you its value is 1. So you have to think about why, and I am proceeding it with this one. So if this product has both the limits are existing, that means then the product limit, that is this one, will also exist, and it will be 1 minus cos x divided by x sin x is nothing but 1 into 1 by 2, that is 1 by 2. You have to think about why it is 1. Okay,
Sir,
yes,
sir, I have a counter example. Like you said, the limit will exist if both the limits exist. Sir, if you take the function mod x by, yes, sir, mod x by mod x,
wait a second. Mod x by
mod x,
mod x.
yes, sir, one function is mod x and one function is 1 upon mod x.
Hmm.
And check its limit at x approach 0. Then, sir, if you check the individual limits, it will not exist. But Uh, now it is existing.
So here I am talking about what? F into G.
Sir,
And you are talking about F by G. And you
sir,
know,
I can take
hmm,
G equals to 1 upon mod x.
wait, when this limit exists, tell me.
Sir, when limit of f and limit of g exist and limit of g is not equal to 0.
G should not be 0 in that neighborhood. When you are moving around this C minus delta to C plus delta, then G should not be 0 in that neighborhood. And in your example, if you will observe that your 1 by mod x is near 0, how this property will follow?
Sir, 1 by mod x, so sir, limit does not exist for 1 upon mod x at x equals to 0.
Yes.
But mod x upon mod x has limit is existing. So if we go by product rule, then it is
What I
not
have
holding.
written here, I am saying this product limit exists if these two existing. If I am saying, okay, let me rewrite it. You are getting confused. Let me write it another way. I am saying if these two limit exist, then I can guarantee about the existence of this product. I am not saying that this product will exist only if these two limit exist. This is not if and only if statement. I am talking about only one side. Understood?
Yes, sir. Yes, sir. Clear.
I am saying ki if this exists, this separate limit exists, then you can say a product exists. But it is not
Sir.
necessary that it should exist, both exist. Okay. So your
Yes.
example is valid for the case mod x and 1 by mod x where one is existing and one is not existing. Okay. So what about the third one? What about the third one? Limit x tending to -1 x cube minus x square minus 5x minus 3 at 1 minus 1. What is the numerator? First of all, what is the denominator? Being 0.
Yes, sir. It will be 0 denominator.
And what about the numerator?
0, sir.
Okay, so that means 0 by 0 form is again coming, and there will be a possibility that this limit might exist. So what we have to do in the case of algebraic, we try to find out those factors in the denominator so that it can be cancelled out from the denominator. So if you will factorize the numerator, so what will be your factorization? Tell me. Anyone?
Sir, x plus 1 into
Yes.
x square minus 2x minus 3.
Again factorize it, because there is a square in the denominator. Is it correct?
Sir, x minus 3 into x plus 1.
So is it correct?
Yes, sir.
So x minus 1 whole square, x minus 3, x plus 1 whole square. So can we cancel out this x plus 1 whole square?
Yes, sir.
Why?
Sir, because we are not putting value x equals to minus 1, we are just getting near to it from right
Near
and
to
left
1.
hand side.
We are not talking about x equal to minus 1. We are near to minus 1. So in that scenario, we can cancel out these two and we can directly substitute, because in case of polynomial or continuous function, and you can directly substitute the value, and this will come out to be minus 4. Okay, now let me move to 8th. Limit x tending to 0, x sin x divided by 2 minus 2 cos x. Calculate this one, and limit x tending to 0, 1 minus cos x divided by x square. Calculate these two limits. So here let me mention one thing, that this question is based on squeeze theorem. So you must know what are the functions from which it is bounded above and below. So this function is bounded above by 1 and bounded below by, I hope it will be now helpful for you to decide. So tell me, what is the limit at 0 of 1 minus x square by 6?
Sir, so how we reached to the 1 minus h square by 6?
Good question. There is an expression called Taylor series. Are you aware about it?
Don't remember it, sir.
See, here I am just giving you this question for the crux to give you how to use squeeze theorem or sandwich theorem, I can say. Okay. Otherwise, don't have to worry about it. If it is difficult, that much expression that you cannot decide from which function this is bounded above or below, then you don't need to worry about it. You will get the inequalities in the question. For example, here I have left for you that sin x by x is 1. So if you thought about it, what is the graph of sin x? This one, correct?
Yes, sir.
What is the graph of cos x? If you draw in this one,
Yes.
what is the graph of x? This one,
Yeah.
and this is graph of 1. So if you observe that sin x by x near 0, what can you say? It is bounded above and below. I'm talking about sin x by x. So it is bounded above by, now it is your task to see how it is bounded above by this and bounded below by this. That is why I left this step for you, because you must need these inequalities of this function bounded above and below. So you don't need to worry that you should know how to do this. If you should know that, then you have to draw either the graph or you have to go with that expansion that I'm talking about. Okay.
Good, sir.
So by squeeze theorem, what is the limit of this left function? 1. And what is the limit of the right function?
1.
So by squeeze theorem, what can you say that?
The middle values limit also 1.
That means limiting value of this x sin x divided by 2 minus 2 cos x is equal to 1. And there is one more also rule that is known as L'Hopital rule, that is used for derivative. We can also use that one also, that tells you that limit x tending to c fx by gx is same as limit x tend to c f dash x by g dash x. And we can use this rule only if f at c is 0 is equal to g at c. That means if there is a 0 by 0 form, or f at c is infinite. If there is a 0 by 0 form or infinity by infinity form, then only you can use this rule. This not has been taught in the class, just I'm letting you know for because of your curiosity. So if you will apply over this sin x by x, it is 0 by 0 form, sin x by x, sin 0
1.
is.
Yes, sir.
So by this rule, what you should do, you should derivative it separately. Sin x derivative is cos x
Cos x.
and x derivative is.
X
1.
1.
Now you can, now is there any 0 by 0 form?
No.
No,
That
sir.
means you can directly substitute. It will give you.
1. Oh.
In the same way you can apply to the second one. Limit x tending to 0, you have to calculate 1 minus cos x divided by x square. Now substitute x equal to 0 in the numerator and denominator separately. Will it give you 0 by 0 form?
Yes, sir.
So when you will differentiate, so it will be 0 minus sin x divided by 2x.
2x.
Now if you will just rewrite it, it will be x tends to 0 sin x by 2x, and 1 by 2 will come out by the property of limit or algebra of limit. Now is it a 0 by 0 form?
Yes, sir.
So again differentiate it. It will be cos x by 1, and this will give you, correct? Understood?
Yes, sir.
Yes.
Now what is the squeeze theorem here? This function is bounded above by 1 by 2 and bounded below by 1 by 2 minus x square by. Obviously in question you have to give this. Only you can calculate the value of this limit by sandwich theorem. Otherwise you need to use this L'Hopital technique. Okay. So by squeeze theorem this limit goes to half.
1 by 2.
Half. So it will imply this will also go to
Half.
clear. Now you understood why sin x by x is 1 at limit at 0.
Yes, sir.
Now do this one. If limit x tending to 0 fx by x square is 1, then find a part limit x tends to 0 fx b1 limit x tends to 0 fx by x. Find these values. This is just a small trick of algebra of limits. If you get it, then you will do it. And I also, we have discussed in that previous question, I'm giving you the hint, the product of limits you have to use here. Now use it. Any answer? Did you get what's what is the technique that I'm talking about?
What part is it for?
Sorry?
Is it for the A part?
Sorry, can you repeat yourself?
Sir, in the first A part, do we need to do f dash of s by 2x?
No, we don't need to do that. It is just a simple property of limit or algebra of limit. You need to use this one, and how you can use it to calculate this, you have to think about it. And I also told,
Sir,
yes,
sir, 0.
yes, 0 is correct answer. How?
Sir, as we see that limit is existing here and denominator x square equals to 0 at x equals to 0, so fx also should be 0 at f of 0.
Sorry, can you repeat yourself?
So here, here we see that it is a form of fx upon gx and limit is existing and gx is 0. So fx also should be 0 at that point to limit to exist. So f of 0 is 0.
Smarter way, a really smart way. But here I am curious to know how to calculate this limit. Your answer is correct. If you use
Sir,
this one, then how will you do the B part?
sir, for B part, now I will use the L hospital rule as you told. Then f dash x by 2x I will get, and in the when I differentiate, then also f dash 0 is 0. Then again I will differentiate, then I will get f double dash x by 2, and that is equal to 1. From
No.
there I will get that f double dash 0 is
How you
equal
know
to
that
2.
F0 is 0?
Sir, I know that because sir, f of x by x square's limit is equal to 1 and
Yes.
x square is equals to 0 at 0. So if f of x is not 0, then this limit will not exist.
Again, the smarter way. Limit x tends to 0. You are saying fx by x square. It has to be limit x tends to 0 f dash x by 2x, and from your point of view you can again differentiate f double dash x by 2, right?
Sir,
Now,
now sir, f double dash x by 2 is equal to 1 from the question.
okay, then
Then we will get f double dash of 0 equal to 2.
how? Here you
Sir,
made a mistake.
that too, sir.
F is not a continuous function. F may not be a continuous function. F may not be defined at f double dash. I'm talking about f double dash may not
Yes,
be
sir.
defined at 0.
Yes, sir, maybe.
That's why I told you. In the first part, you can use your smarter way or the trick, but in the second part, you again have to come back to that product rule that I'm talking about. Any
Sir,
other answers? I told you that f into g exists if f and g both are existing. Did you remember that?
sir, you told in the other way, if f and g exist, then f into g will exist. But that will not imply that if f into g exists, then f and g must
I
individually
also
exist.
said the same thing, that if the product limit exists if both separate limit are existing. Now it is correct.
No, sir, you have written it in the other way.
If this exists, then this exists. Correct?
Sir,
What if I say that limit this exists if this is existing? Is this the different statements?
yes, sir.
No.
Sir, in like if you have written like if limit extending, if individual limits are existing, then product limit will also exist. But we cannot say it in the reverse way, na, ki if product
I'm
limit
not
is
saying the reverse one. I just wrote in a different way. Where is Akshay?
Yes, sir.
Did these statements are different?
No.
If limit x tends to c fx and limit x tends to c gx exist, then limit x tends to c fx into gx will also exist. One is this statement and another one is this exists. Is these two statements are different?
No, sir.
Now tell me the what's your name? I don't remember. Was there?
sir, yes, sir. I think these two statements are different, sir.
These two are not different. I'm not saying that.
Sir,
I'm not saying you are thinking about. Let me complete. You are thinking about if this product exists, then are you thinking about this one?
yes, sir. I am saying this one that the last statement you wrote is not right.
I am again telling you this means this exists if this existing. If this is not
Okay,
exist,
sir. Okay. Yes, sir. Yes, sir. I got it.
okay. Now you got it.
Yes, sir.
Good. So here fx by x, you know about fx by x square, but you don't know about fx. So can you rewrite it in this form? Think about it. Can we write like this?
Yes, sir.
Why we can write like this?
Because x square is cancelling out.
No, no, no. Why? How can you cancel out? That's my main point.
Sir, because x is not equal to 0, it is only
Exactly.
approaching it.
It is near 0. So you can multiply and divide by any quantity which approaches to 0. Correct? So now tell me, I told you if this limit and this limit separately exist, then this product limit exists. Correct?
Yes, sir.
Archit.
Yes, sir.
So what is the limit of this separating? This is 1 and this is 0.
Yes, sir.
So what will be the product limit? Limit x tends to 0, fx by x square, limit x tends to 0, x square. Can I write like this?
Yes, sir.
Now what is the value of this 1 into 0? It is
0.
0.
Now tell me in the same way, can you calculate fx by x?
Into x by x.
Sorry?
Into x by x. Then can be separated.
You mean this?
Yeah.
Akshay? Okay. So you can separate it now. So it will be 1 into 0 again and answer will be
0.
Is it clear now? Archit?
Yes, sir.
Okay.
Sir, can I ask one doubt?
Yes, please.
In every limit function, if the denominator is 0, tends to 0, then is the numerator always tends to 0?
Two limit exist. To the whole quotient limit exists, it should be there.
Okay.
Otherwise, limit will not exist.
Okay, sir.
So let limit x tends to b, fx is 7, and limit x tends to b, gx is -3. Therefore, find limit x tends to b, fx minus gx. Limit x tends to b, fx into gx. C part is limit x tends to b, fx by gx. I hope this is the easiest one. So tell me quickly. What are the answers?
First one, 10, sir.
Second one?
Negative 21.
Third one?
Negative 7/3.
Okay. So limit x tends to b, this will be fx minus limit x tends to b gx, and this is happening because both the limits are existing. So it will be 7 minus minus 3, this will be 10. In the same way, limit x tends to b fx limit x tends to b gx. So it will be 7 into minus 3, that will be minus 21. Now limit, since gx is non-zero near that neighborhood, thus we can say that it will be limit x tends to b fx divided by limit x tends to b gx. So this will give you minus 7 by 3. Is it clear to everybody? Okay.
Yes, sir.
So the last notion of the class is sine and cosine rule. What is sine rule? Anyone is aware about it?
Yes, sir.
What is that?
Sir, in any triangle, sine of any angle
Hmm.
divided by its opposite side
Hmm.
will be equal to sine of any different angle divided by its opposite side,
Hmm. So
and it will hold for
let
yes.
me take it precisely. This is ABC, a triangle, okay, and opposite of this angle I am calling it side small a. Opposite of this side I am calling it small b. Opposite of it I am calling it small c. So sine rule says that the ratio of a by sine a is same as b by sine b is same as c by sine c. Is it clear? Next one is, in the same way, with the same notion or notation, what is cosine rule?
Sir, cosine of any angle will be equal to sum of squares of the adjacent sides minus square of the opposite side upon 2 times of the adjacent sides.
Okay. The easiest way to write it, that a square is equal to b square plus c square minus 2bc into cos of
See.
opposite angle of this a. In the same way, if you write for b square, it will be a square plus c square minus 2ac, opposite angle of this one, cos of b. And c square will be a square plus b square minus 2ab cos of a. Any doubt? You just need to you don't need the proof of these, you just need to remember it. So on this we have our last question of this class. So in triangle ABC, let a is equal to 4 unit, b is equal to 5 unit, and angle C is equal to pi by 3. Now find the value of sine B. Try this one.
Sir, one doubt.
Yes.
So in the formula, c square equal to a square plus b square minus 2ab cos c, right?
Oh, sorry. Cos C. You're right. Just opposite angle of this side. Thanks.
Sir, 5 by 2 root 7.
5 by 2. No. Sorry. Wrong answer. Try again.
Sir, 5 by 2 root 7.
Wrong one.
Sir, it's correct. 5 by 2 root 7.
How?
Sir, first we will find the side C by using cosine rule.
Side C by using cosine rule. Okay.
Yes, sir.
So C square is equal to A square plus B square minus 2AB cos C. So this will be 4 square plus 5 square minus 2 into 4 into 5 into cos pi by 3. So this will be 16 plus 25 minus, this will be cos pi by 3 is,
1 by 2.
so this will be 26. Sorry.
Sir, it's easily 40.
Sorry.
Isn't that number 40? 5
Wait,
into
wait, wait,
4,
wait, 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 wait. I made some mistake. Yeah. So it will be 21, right?
Yeah.
Yes,
Root
sir.
So now A by sin A, B by sin B. What is A?
4.
4 by, have you
But
given
sir, we
sign?
do not know sine A.
5
No,
into
sir.
yes.
Sir, C. We can use C. C by sine C.
C by sin C. Okay. So you know B, 5 by
Yeah.
sin 21 divided by sin C.
Sir, we do not know. Sir, C is known.
Sorry. Is it correct now?
No, sir. The C, it is
Sir, root
root.
21. C is root 21, sir. C square is 21.
I apologize. cosine rule, and this is by sine rule. So under root 21, is it fine now?
Yes, sir.
So sine b will be 5 by under root 21, and sine pi by 3 is
Root 3 by 2.
so it will be 5 by 2 root. That's what you were saying?
Yes, sir.
Yes, sir.
Then it's correct. Sorry, maybe I have not solved. I did not cut that root under 3, so that is why my answer is a little different. So any doubt from this class or the previous one?
No, sir.
Okay, then let's meet to next Tuesday, same time. Okay.
Okay, sir. Thank you.